Have been working with solving equations, and we have learned that it has one solution. So we've been working with one solutions, and when we have been solving equations, we've made sure that the variable is on one side. And when we talk about the variable, that's something like 3x. It has that letter attached to it. And when I'm talking about a constant, that does not have a letter attached to it, like 5. So when I'm solving for equations, we have learned, just a reminder, when I use a Flair pen, you use Flair, and when I use black, that's your pencil. When I'm solving equations, the first thing I do is make sure everything is simplified before I move things left or right. So now I have x minus 8, so negative 4 times 2 is negative 8, and a negative 4 times a positive x is a negative 4x. And on this side, I'm going to move that equal sign a little bit higher. And on this side, I have, it's already simplified. I cannot combine those two. And you guys have been fantastic solving equations. Now I'm going to combine my like terms. And I have a negative 3x minus 8. And over here I have 7 minus 2x. And I'm going to add 3x to both sides. And that goes away, and I have 7 plus x on this side and a negative 8 on this side. I run out of room, so I'm going to rewrite it over here. And I'm going to solve for x, so now I'm going to move my constant to the other side. So now all my variables are on the left, and my constants are on the right. So here I have my one solution. We're not going to check because of time, so I'm going to move on to the next step. So what happens when I have an infinite number of solutions? What does that look like? So that means any number works. So I'm going to underline the word any. That should be in Blair. Any number works. So what does that mean? Well, let's test 3. So does 3 work for this equation? So I'm going to write negative 2 times 4y plus 1 equals negative 8y minus 2. So I'm going to substitute 3 every time I see a y. And I'm going to see if 3 is an answer. So I'm going to focus on one side first. So I have a negative 2 times 4, and there's my y, and I'm replacing it with the 3, plus 1. And that's all in parentheses. And again, I'm going to simplify the left side first. So 4 times 3 is 12, plus 1 is 13. So I have 13, and then I will multiply by negative 2, which gives me a negative 26. So this side is negative 26. So when I substitute 3 for y, I want to know, what does the right side equal? So I have a negative 8, and every time I see a y, I'm substituting that 3. And then minus 2. Using order of operations, I'm going to simplify the right side. So this gives me a negative 24 minus 2. And since signs are the same, I'm going to add them, and I have more negatives. Now, this is a true statement. That means 3 is an answer. So yes, 3 works. Well, does 1 work? So we're going to do the same thing again. I'm going to have negative 2, and every time I see a y, I'm replacing the number 1 in there. And plus 1, plus 1. And now I'm going to work the left side. So 4 times 1 is 4, plus 1 is 5. Times a negative 2 gives me a negative 10. I'm going to write the original. I should have done it. So what I'm doing is I'm writing this piece here, negative 8y minus 2, and every time I see the y, I'm replacing it with a 1. So I have a negative 8, negative 8, it's not giving me blank, negative 8 times 1 minus 2. There we go. For some reason it's not registering. And using order of operations, I'm going to work this out. That gives me a negative 8 minus 2, and that also gives me a negative 10. So this side and this side are both negative 10, so this is a true statement. That means 1 also works. So that's what we mean by infinite number of solutions, that any number I choose will give me a truth statement. So how do I know if it's going to be an infinite number of solutions without checking every number? So we're going to show it algebraically. So the first thing I do is I'm going to simplify each side. A negative 2 times 4y gives me a negative 8y. A negative 2 times 1 gives me a negative 2. So the left side is simplified. So now I'm going to simplify the right side. It is, so I'm just going to bring it down. So now I recognize that I have y's here and y's here. Now notice that they're the same. So I'm going to move them to the left side. So I'm going to add 8y from both sides. And that disappears and that disappears. My y's, my variables disappeared. So now I have negative 2 equals negative 2. Well, this is a true statement. When this is the case, my variables disappear. And I have nothing but my constants, and this is a true statement. That means I have infinite number of solutions. Infinite number of solutions. Now let's look at another example. So I want you to focus on my coefficients when we simplify each one. Notice on this one, I'm going to highlight my coefficient for this one was negative 8. And this one was negative 8 on the other side. Notice that they were the same. That's why they canceled out. So when I'm looking for things, I'm checking that if the coefficients are the same, I know they will disappear. So looking at this one, I'm first going to distribute this side. A negative 3 times a negative x gives me a positive 3x. And a negative 3 times a negative 4 gives me a positive 12. And on this side, I have 3x plus 12. Again, notice that my coefficients are identical. Those coefficients, which is the number in front of the variable, are identical. When that happens, I know if I subtract 3x from both sides, because I'm moving them to one side, they will disappear. I have 12 equals 12. And notice my constants were also the same. This gives me a true statement. So I know I have infinite number of solutions. That means any number will give me a true statement. Every number on the number line will work. So when I'm looking for infinite number of solutions, I know my coefficients will be the same and my constants will also be the same. Okay. Will there ever be the case that I have no solutions? So I want you to highlight no solutions, and that means nothing works. And we're going to pay attention to those coefficients and those constants. So the first thing I'm going to focus on is simplifying both sides. 3 times 5x gives me a 15x, and 3 times 2, positive 2, gives me a positive 6. And on this side, I have a 15x. I'm going to highlight my coefficients. Notice they too are the same. So I'm going to subtract 15x from both sides, because whatever I do to one side, I do to the other. And I get 6 equals 0. Will 6 ever equal 0? Never. So this is a false statement. That means nothing will work. So this is what we call a no solution. When I'm looking at my equations, my coefficients are the same and my constants are different. So that's the key element here. Okay, let's look at this example here. I'm going to simplify both sides first. possible. So negative 3 times x gives me a negative 3x. And negative 3 times a negative 2 gives me a positive 6. So that's simplified. I cannot combine like terms. Now I'm going to bring this down. I have 3x plus 4. Now I notice that these are the same. My coefficients are the same. I'm going to add 3x because that's how I would get rid of them, send it to one side, but they both disappear and I'm left with 6 equals 4. This is never true, so this is false, which gives me a no solution. Now, this was not printed, so you will have a second page given today. So you'll make sure you look at this, add this to your packet. So here you have, I made a chart. When I have one solution, my variables stay, they do not disappear. So I will get something like x equals 7. When I have no solutions, my variables are eliminated and a false equation is left. For instance, I would have something like 7 equals 9, which is never the case, so that would be a no solution. When I have infinitely many solutions, my variables are eliminated and a true statement or equation is left. For example, I would get something like 12 equals 12. Now here, it's kind of like a chart to help you look at things without actually solving it. How do I know if it has one solution? So when my coefficients are different, so I want you to write the word different, I will have one solution. When I have no solutions, my coefficients will be the same. So let's make that the same color. These will be the same. But my constants, that's the number without a variable, those will be different. Let's make that green. Those will be different. This is when I will have no solution. This is after I've simplified everything, so make sure you simplify everything. And when I have an infinite number of solutions, I will end up, when I'm looking at the coefficients, my coefficients are the same, and my constants are also the same. We really refer to this as an identity. So notice how the left looks identical to the right. That's what we call an identity. So when those are same, I know I will have an infinite number of solutions.